Okay. Ladies and gentlemen, FYI, this new / old document camera doesn't have a mic in it, so it's my laptop mic. So when I turn my head this way, it tends to get a little bit tinny on this side of it. So I'm just going to try to speak as loud as I can, but do what you will with that. Know that the video is just going to maybe have some Charlie Brown moments on it. Okay, calculator. Got your calculator? What is the base on all of these logs? Log 10. Remember that your calculator only functions in log 10. Okay? What are those types of logs called? Common logs. All right. Handy dandy calculator. So we are going to do log 6. Mine automatically opens up brackets, so I have to close them. And then I'm going to add log 5. And I'm going to hit enter. That's it. Isn't that exciting? No, we don't have time for that in our lives. Okay. You ready? Do the log of 99. That's exciting. Okay. Log of 30. Exciting. Oh, you guys have just discovered a log law. Oh my God. And what do you anticipate without doing it on your calculator is the value of the last one? That same thing. Oh, so exciting. So exciting. You just discovered a log law. You've discovered the product law or theorem, whatever you want to call it. So the log of a product of two factors is equal to Isn't that exciting? Super exciting. So you guys discovered this. This was log 30 had the same value as log 6 plus log 5, right? So we know that the factors of 30 can be broken out into these log laws. They're really super similar to your exponent laws from grade 9 or grade 9. When you multiplied, what did you do to the exponents when they had the same base? You added them. Not to ruin the fun, but okay, pretty exciting stuff. Anybody want to guess what the log law is for the next one? Dividing, right? So which ones do you anticipate to be worth the same?
1 and 3.
So we anticipate this and this one to match, and that one to match. Because we're smart people. We see patterns. Okay, so I just did the first one there. So log 12 has the exact same value as the one we anticipated to happen. So what's log of 36? Spacing on this is weird. Okay, so you have just discovered the quotient theorem. So the log of a quotient of two factors is equal to the difference. Okay, power theorem. We did, it was on the other page. Okay. Okay. So which ones do you think are together? Okay, so let's talk about this for just a quick second. So I did log of 49 in my calculator, but how would you approach this in your calculator? Log 7 times 2, right? Like, so you're doing the log of the number 7, and you're just doubling that, right? So really what it is 2 times by the log of 7. So you're going to perform the logarithm. Some calculators can handle it if you put it in just like that. Other calculators can't. So just double check how your calculator can handle it. Can you put in the 2 and then the log 7? Because you know what it should be equal to. Okay, did you guys get that? Do you know how to do it in your calculators? Okay, perfect. Did you do these two? Yeah. I feel like nobody's doing it. Everybody's having conversations that are not nearly as fun as the math. Okay, so the log of a factor to a given power is equal to the power. What are we doing with the power? What's happening here? The exponent comes off here and we multiply it by the log. That's not a very big line. Okay. Okay, so big text box there. Same sort of rules as the exponents. All the theorems only apply if the logs have the same base. You can't apply a log law if you're looking at a base 2 log and a base 3 log. Okay? Okay, let's look at the first one. Nice and easy. Can I do log laws on this one? Yes, they're all base 2, so it's good. So they're added together. So that's the product law. So what is that? So log base 2, argument 32. Without using your calculator, can you evaluate that? 5. Okay, put that into exponential form. What do you set it equal to? You set it equal to some variable. I'll use x because I get just skewered if I don't. Exponential form, so 2 to the exponent x equals 32. Can we write 32 as a base 2 number?
Yeah, 2 is not bad.
So we need to be really specific about this, is that you do not divide the 2's out. You're just actually ignoring them for a second because you've said these things are equal. Does that make sense to everybody? You can't divide them out and just have exponents hanging. That would be bad. Okay, let's look at this. Let's look at this. Okay, what's happening? Okay, brackets, super important here. How do we read equations? Left to right. So we're going to do the math left to right. Okay, or Bedmassing it for sure. So let's talk about this for a second. This is going to be 4 log 2 x, and then these are subtracted. So what happens? Divide. And then we've got this on the end. We've got that on the end. So what are we doing with it? We're adding it in, so what happens? We're multiplying it.
Do you use the power term on the first term?
Okay, maybe that was, sorry. Sorry.
This is why I don't write anything for
So this is going to be x to the exponent 4 divided by, I added another log in there and I was going to write it as another step, but, so it's just the arguments that are divided, not the logs. No, you can't, because they're not the logs that are divided. It's only the arguments that are divided. Sorry. And then we are going to times it by.
Where did you get x to 4?
What's that? 4. And what is it? We're using the power of a power here, right? Right above it. So if it's in front, where does it go on the argument? It changes into the exponent.
Can we expand the x
Nope. But we would have x to the exponent 4 times x squared plus 1 all over x minus 1.
Well, very limits.
We're not going to be able to evaluate that one just because there's x's in there and we don't know what it's equal to. That would be the problem that you had in question 2.
Okay.
So we can't evaluate this one. This one can't be evaluated. So we can evaluate this one because it's all numbers. But, okay, try to evaluate that one. What are you going to set this equal to? A different variable. And then you're going to have variable k. Like if you put this into exponential form, you're going to say that's equal to k. So it's going to be 2 to the exponent k equals x to the exponent 4 times x squared plus 1 over x minus 1. You can't do it. How come? Because I have, no, you don't have another equation that's equivalent. So I only have one equation. So I can't have a system with one equation. So I have a k and I have an x, so I can't solve it. So that's it.
Yeah.
So, okay. All right. Your uncertainty is interesting. Okay, can I flip the page? You need to finish it? All right. Okay, now we're going to expand it. We're not evaluating, we're just going to expand. So you're going to use the log laws to take a single log and write it out bigger. Use your log laws to write this out in expanded form. Here, it was given in expanded form, and you wrote it as a single log. Can you do the opposite? I want you to go from here back to here. I think the first thing I would do is I get rid of my radicals, and I change them into exponents. So, log base 3, x to the exponent 1/2 times by y squared over x. I'm doing it with my grade 10s. We're just finishing up this unit, so it's fresh. What kind of root do you have? Right, and what's the exponent on the x? It's just a 1. So your numerator tells you what your exponent is. Your denominator tells you what kind of root it is. So if we hop over to here and change this one, what would the exponent be? 1/3. So this one would be x to the exponent 1/3. Because you have a cube root, the exponent on the x is 1. There you go. Welcome to grade 10. Okay, what is happening with the numerator? Are they multiplied? Multiplied, so what does that mean in log laws? We're going to add them. So we're going to have log base 3, x to the exponent 1/2, plus log base 3, y squared. We're going to do it in the next line, okay? Baby steps. And now we're dividing by x. So what's that going to be? Minus. So log base 3 x. Now we still have to apply our power law. So what does the power law say? What do we do with the exponent? It comes from the exponent out to the front as a coefficient. So this would be 1/2 log base 3x plus 2 log base 3y minus log base 3x. Yep. Well, I'm going to ask you to use these laws in a way that isn't, that might not feel comfortable. So we'll go from there. Okay, let's look at B. I'm going to switch colors. That's it. That's expanded form. You're done. You can't simplify it. You can't evaluate. Well, we could. It was simplified. Now we expanded it. You can't evaluate it because we have x's in there and we don't know what we have x's and y's in there. We don't know what they're equal to unless it's equal to something else, like unless it's equal to a number. Okay, let's look at the next one. So, what's happening with these two on the top? There's no base stated, so it's 10. You don't have to write 10 in there. You can just leave it off. So the numerator is being multiplied. So we're adding them. So we have log x to the exponent 1/3 plus log x to the exponent 4. Okay, if you were comfortable, you could have jumped and done the power law right away. You do not have to do this step. If you can see it, you can put those right out in front first. Now let's talk about the denominator. So we need to use brackets because what we want to do is we want the denominator to be multiplied together, but we need it to be divided by the numerator. So we're going to say subtract. We could say subtract and then these two added because they're multiplied, or we could say subtract, subtract.
Subtract and added, I feel like that.
I feel like subtract and added is the way to go. Ooh, running out of room. Because really, if we distributed this negative through, it would be a subtract, subtract. But this indicates that these two things are multiplied on the bottom. So you got to use your brackets. So now we're going to apply the power. So we're going to have 1/3 log x plus 4 log x. Oh, it's an argument, not a base. Minus bracket 2 log y plus log x. And I'm running out of room. Sorry, it's right on the edge of my page. That's it. Was that terrible? Terrible. Terrible. We did not. Because everybody just got them back yesterday. Okay. All right. Okay, so now we're going to apply our rules. And this is where you're not going to be happy, but it's not hard. So a question like this could be given on a non-calculator portion because it's evaluated it for you. So log base 8, 2 has a value of 1/3, like 0.3 repeating. And log base 8, argument 3 has a value of 0.52852. So we've been given those. And we're going to find log of 18. So if we know what the argument 2 and 3 are worth, we can figure out if 18 has factors, which it does. So we are going to factor out 18 till we only get factors of 2 and 3. 2 and 3 and 3. So 18 can be written as 2 times 3 times 3. Well, what's 2 times 9? 18. But I have no information about 9. I'm looking for arguments of 3 and 2. So that's why I broke them down specifically into those factors. All right, so if you know that log 18 is the same as 2 times 3 times 3, can you write that in expanded form? Yes. Pardon? Write it in expanded form, guys. They're multiplied. So what's the log law for multiplying? Adding. So this is log base 8, 2, plus log base 8, 3, plus log base 8, 3. Switch them where? There's no powers. There's no exponents anywhere in them. Is there an exponent on the 2? I mean, we could have used 3 squared. That could work too. But we didn't. We wrote them out as just factors. So what do we know this is worth? 0. And what do we know this one's worth? Okay, Can you add those together? No, you can do it without a calculator. Stack them on top of each other. Go old school. You don't need a calculator to do this, ladies and gentlemen. Oh my goodness. One question on a past provincial exam was to use shapes for this question. Yeah. Like say that this was equal to a moon and that one was equal to a star, and then what would this look like and how many moons and stars would you have in the end? Yeah, so you guys are complaining about digits that are obvious that you add together. Moons and stars were a little bit out there. And Amber's going for her calculator. 1.09.
Carry the one.
That? Okay, good adding. Good adding. Old school. Stack them on top of each other. Start adding digits, carrying the ones over into different place values. So applying a log law, this was a question that students struggled with on the exam, but like when you look at it and have a little bit more experience with it, it's not as terrible as it originally looks. Are all the questions on the provincial exam, say again? No. In a traditional exam, you're probably going to get 3 to 4 that are, I'll call them second level kind of thinking, right? It's not like graph this, right? Like you've got to know something about it and apply some thought before you can get there.
How many on your provincial exam?
17.
Okay.
No. Maybe. I don't know.
17 trick questions.
I didn't say that. I did say that, but okay, I did say that. It's on video. Okay, how are you going to handle this one? You're doing the exact same thing. Okay, first of all, I think the thing I'm going to do is I'm going to deal with the exponent of a half right away. Is everybody okay with that? Okay, I have no information about log base A10. But what do I have information about? We've got 5 and 2.
Yeah, so now we do like 5 and 2 on top divided by the 3.
Yeah.
Very nice. Okay. Ooh.
Oh, 5 times 2, sorry. Is that better? Sorry.
The log 5 plus log 2 minus log 3.
Okay, so what are we going to do with that exponent?
The power.
We're going to bring it in front, but it's going to be applied to all of it.
So then do we add it to our log base 8?
We are going to pull it to the front of everything. So I have no idea what I just didn't do. That's like as soon as I put the square bracket, it's like, oh my god, I'm lost. Oh my god, I'm lost. I don't know what to do here. Concentration in band? Oh, I was like, in band? What do square brackets have to do with band? A lot of things. You can put round brackets if it makes you feel better. Okay. All right, what do we know? We put in the values. So log 5 is 0.8271. Log 2 is 0.3562 minus 0.5646. So because that square root was applied to every of all the factors, I mean, you could have done half of this, half of that, and half of that, and then added them together. But to me, it makes a little bit more sense to do all of that. You can have your calculator.
I don't even remember like division, like stacking, like borrowing and stuff.
Borrow? For division?
No, for subtraction.
Oh, for
Remember, like,
you don't.
I forgot. I go.
Whew. Wait till we get to synthetic divisions. I used to teach how to divide polynomials by binomials, long division method. But it was rough. Okay, what do we get? 6187. And did you times by the 1/2? What? You didn't yet?
My mom used to be so proud of me because they knew I was like complex borrowing stuff. While everyone else was doing standard. Yeah, like that. No.
Okay. Not terrible. Not terrible.